everyone, welcome back to another Fireside Chat with Brian. Brian, thanks for joining me again.
Happy to be here. We have no fire, but
we have a plant.
Yes.
So last time, our Fireside Chat's topic was Shackle, data validation. Uh-huh. Ultimately, we learned that it rolls into data quality and governance. And a question that is frequently asked in that space is, do you trust your data? And I think for a lot of folks, they correctly assume that means, is the data timely? Is it accurate? Is it maybe duplicated? Those sorts of things. For Fluree, we have, I wouldn't say a separate take, but we have an evolved take on what we mean when we say, do you trust your data? And we brought in some digital technologies, including some inspiration from distributed ledger technology to help that. But Brian, I want you to explain how, with Fluree, our goal is to enable decentralized data collaboration. And so how does that fit into our design decisions around bringing digital trust into the fold, into our knowledge graph?
Yeah, I think that it's a good question. There's just a lot there. And I know we don't want to talk about this forever. So try and get a little organized. So I think for starters that there is a lack of understanding until there's a serious issue about how untrusted most data is in organizations or in general. How many people have their hands on that data? How, if that data has sensitive information in it, how controlled or protected it is. And I would say that for most organizations, if they really gave an honest assessment of this, they would have a lot of failing grades, right? So does it matter? Well, of course it matters, but it matters most when looked at through a lens of risk. And the risk of those vulnerabilities being exposed is getting higher and higher. And AI is certainly, a catalyst of that. Of course, we've seen many examples with AI starting to output data that people didn't even know it could get into, right? And so the more that we're leveraging this data in strategic ways, the higher risk we have that, data that isn't properly protected gets exposed in some ways and creates an issue. So I think this is front and center. I think we're just going to see throughout 2024 and the years coming, example after example after example of these issues happening.
Yeah, and certainly AI is a catalyst, and it was only going to take so long for us to talk about AI and trust in the same video. But there are other catalysts too. I mean, people are increasingly opening up sharing agreements for data. Enterprises are increasingly trying to get data into the hands of its workers faster and at a higher rate. And so with every instance of sharing, if you're looking at it through that risk lens, the risk is high and the need for digital trust is also high. So let's get into defining, at least from the Fluree perspective, what do we mean when we say digital trust, and what are some of the technologies that we use to facilitate digital trust?
Yeah. So I think challenge number one is to better leverage data. The kind of standard practice right now is you copy and paste the data into a data lake or a data warehouse. And then there's going to be a group of people who have access to everything in the data lake or data warehouse who can literally see everything. And how much thought is to put into what data is there and who those people are is maybe, an area of interest for at least some organizations to think about. But of course, we still have the challenges of how do we then expose that data or leverage that data from there. Our approach is decidedly different than that. So our approach is we don't want to move data around and actually increase the risk of this data being exposed. We want to enable that data to stay where it's at for the most part and be able to wrap control, insights, knowledge, sort of mapping capabilities and turn it into a data fabric, right? This decentralized kind of approach. Of course, that brings different challenges, right? So the reason you copy and pasted everything together is that it was the only way to query across it. Well, so we have to have ways of querying across this decentralized thing. And it's like, boy, wouldn't that be slow? So we have to work on ways to address the speed. And these are all things that we have been working on, of course, for years and have really great solutions to. So the decentralization starts to bring up this trust issue.
Right.
And I think the best analogy that I still have is the web. You know, anyone can put up a web page anywhere on the internet. And sort of along the same lines, what we're saying is anyone could put up data anywhere in the internet. So what are the things that the internet had to provide to help trust things, to make sure when you put your credit card information in something, it wasn't stolen, to make sure when I go to google.com or microsoft.com, I'm really on those companies' websites and it wasn't hijacked and I'm not on some hacker's website. All of those same types of techniques need to come into this data tier. And that's very different. And that's something that Fluree focuses on. And I would argue even takes up a couple levels from what you see on the typical internet approach.
So you need that little green lock icon in your browser, but for data. So if I was to extrapolate on that, where did this data come from? Who originated it? And proof that it hadn't been manipulated across its life cycle. So let's maybe talk about those things and the aspects of how does Fluree Core actually organize around these ideals?
Yeah, so proof that the data is who someone said it is, I think, is the table stakes. And there's a few ways to approach that. We approach that, and we approach almost all of these problems through cryptography, which is the logical approach, of course. So we approach that with digital signatures. And digital signatures can verify the packets of information, and in this case, we're talking about data, maybe the result of a query, maybe a whole database kind of moving or whatever, that the packets have a signature where the recipient can verify that no one intercepted that data at any point in time, changed that data somehow without you knowing, or that data, even though I thought it was coming from Kevin, I can verify it truly came from Kevin. It didn't come from somewhere else. The other thing is we need to encrypt that data while it's flowing over the pipes, right? So we use encryption to make sure that if anyone could listen into the network, they don't get anything useful. The person receiving it can obviously decrypt it, but then they need to verify that it hasn't been tampered with and that it truly came from Kevin. And these are all things that we see, I use the internet example with that little green rock icon. That's exactly what that is doing and assuring you that all that work has been done for you. You don't need to worry about it. Of course, with data, we're talking typically about machines talking to machines, but they need those same assurances. The other thing that we uniquely do at Fluree is we track how that data has changed over time, and we can prove that data said a certain thing at a certain moment in time. Use cases around this vary, of course, auditing and things like that. This could be important. We have some clients that leverage this feature of ours for digital evidence management or other things like that. But for the most part, it's just super valuable to reproduce results. And you can't reproduce results unless you can command the dimension of time. Mm-hmm. And so that's why time is just a fundamental characteristic of our product. And when we think about time, we're also wrapping all of these changes as well in cryptography, just behind the scenes. If you care about it, it's there. If you don't care about it, you don't even have to know about it. It's just kind of happening, in the background. So that's another big area of proof that we do, which is, to my knowledge, I have never seen another technology do that.
Right, so you're really combining elements of identity in the form of cryptographic signatures and immutability for historical audit trails. You mentioned time travel queries, so you can query the database as of any moment in time and get that query back. You could also query perhaps a subject and review its complete history from the time it was originated till today, all its manipulations.
Yeah.
And so now I do want to talk a bit more about AI, because I think clearly, well, in my mind, maybe you can think of a few more. There's two really interesting use cases for digital trust technologies, or at least immutability. The first is just in terms of training and reviewing. Having a historical audit trail of data over time sounds like it would lend itself very well to training an algorithm and adding a bit more explainability. So I want you to perhaps talk about that. And the second is ML poisoning or AI poisoning. That's a practice that's a little bit more malicious than just training. It's where we're actually injecting, or a potential hacker or a bad actor is injecting false or otherwise unwelcomed training data or real data, instance data, into the source that the AI is using to make its decisions. And so those are clearly connected, but one is more on the training side and one is more on the security side.
Yeah, and both are very easily handled with Fluree. So for one, when we're ingesting data and training models, we have built into the data here this ability to have cryptographic proof that the data hasn't been tampered with. So it's quite simple. It can just sort of happen in the background. As it relates to the time travel and sort of reproducing results, that is, there is cryptography and trust involved in that, but the real value there is being able to reproduce results, being able to iterate more quickly and improve, especially with data. We have source control on our software, and this allows, and anyone who is in software development could not imagine working on a team without source code control.
Without GitHub.
It would be a mess. Right. So we absolutely need these types of features of understanding what changed by when, who, branching, all of these things. Well, when we're talking about training models and doing these things with data, we're sort of working with data the same way we work with software, source code. Mm-hmm. And if we're missing those features, it just makes life so hard. We're reproducing work all the time. It's hard to experiment and say, okay, I'm going to tweak this and do something a little different. And Fluree brings all of those same type of capabilities, but to that data tier. So it really enables a improved workflow, reproducibility. I know we've said that word a lot of times. I think that's going to be increasingly important in the AI space. Just a lot of sort of better life kind of features into trying to make all this work.
So just backing up a little, I want to talk about Fluree's value to the world in terms of, we want this data-centric enterprise. We want data to be decoupled from its apps and provide value to any possible range of future data consumers. We're talking about trust. We're also talking about semantics, which we've talked about in the future, and perhaps we'll talk about security as well. But just looking at the scope of trust, let's talk about, let's end this video on our favorite use cases from current clients. My favorite use case is in the food supply chain space. There's a client of ours that is using Fluree to digitally track halal beef as it moves across borders and as it moves across the food supply chain. And it actually ends up at a grocery store. Consumers are scanning the beef with QR codes, and they have this full, complete audit trail of where their beef came from. I think that's a really cool use case. I know I'm putting you on the spot, but do you have any favorite use cases?
We have a few cool ones, but the one that I love and we continue to work very heavily with is the Trusted Learner Network. Yeah. And the reason I love this one is because it is, at its core, the ultimate of a decentralized database. Because what we're doing there is we're basically creating, using the verifiable credential standard, but it's all the things we've talked about. We're taking data, semantically self-described data, we're wrapping a cryptographic proof around it. That cryptographic proof shows that it originated by University X or University Y, and it acts as a digital proof that you actually earned a degree or you had credits or you did whatever. The cool thing is that it can be stored on your phone, in a wallet on your phone, or anywhere. And because it's self-describing data using the same standards that Fluree uses at its core, as long as someone makes that available, and it's up to them to make it available, so it's self-sovereign, right? You decide to opt in your provable data. Anyone can verify that that data has integrity. It really came from the source, even though I don't need to go talk to University X at all. Everything I need to prove it came from University X can actually be provided in this case by the student. But we can actually bring some of this together and run queries across this whole decentralized network for this type of data. And it's a really cool use case. And I'm really excited for people starting to do similar things using these similar standards for healthcare records. You know, putting your healthcare records on your own personal wallet, on your own personal phone. You decide who and how those get shared. Financial records for proving things about, you know, if you qualify for a mortgage or a car loan or, you know, whatever the case may be. These are all things that can be done in a completely decentralized but still heavily trusted way. They all are based on Fluree and how we handle data.
I love use cases where we can talk about it from the value of the consumer perspective.
Yeah.
You know, applying for a mortgage could be easier. Getting access to your health records could be easier. It's really, those are my favorite use cases to talk about.
Yeah.
All right, Brian, is there anything else that we didn't cover related to digital trust that perhaps we should have?
Well, there's a lot we didn't cover, but I think that's probably enough for today.
Okay. Well, thank you so much, Brian. I appreciate your time.
Of course.
Thanks, everyone, for listening.
Thanks.
Take care. Hey, thanks so much for watching. Don't forget to like and subscribe for future updates from our channel. Visit us at Fluree PBC on YouTube and Twitter, on LinkedIn as Fluree, or on the web at flur.ee. See you next time.